Okay, this is theory on working drawings, and before you even get into working drawings, you have to know how to create assemblies that are better constrained than what we've been working with. There are three basic forms of constraints, if you would call them, to create an assembly. So I've created some parts earlier. I'm going to bring them up. We've got a front part. Okay, has a tapped hole at the right, and also has a counterbore feature. Okay, and then we have the rear part. So we're going to open it up. It is a mating tapped hole that ties in with the front part, and also has a tapped hole here on the right. And all these holes have reasons. To create an assembly, one of the first things you're going to do is go into the File, New, and you're going to open up an assembly within SolidWorks. And then you're going to place parts. I always like to, and you should always have your origin on. And I'm going to grab the rear part, pull it in, and once I cross over the origin of the assembly, you're going to see the two origins are going to coincide. You always need to have a base part, and then everything sort of forms off of that. Okay, so in this case the rear piece is that base part, and I'm going to save that, and we're just going to call it test for right now. Remember, everything's always in capitals. Makes it easier for you when you're creating automatic title blocks. So the assembly now has this in here, and if you look very closely, right in front of rear part it says F. That means that that part is fixed in position and it's fixed on that origin. The next part we're going to insert is an existing part, and it's going to be front, and we're just going to drag it in here somewhere. Okay, and this is where we're going to get into different ways of constraining things. Now, if these parts are always the same, and in this case they're 4 inches wide and 2 inches tall, one of the easiest ways of constraining part number one, or the front to the rear, is you're going to grab this, and in the book they call it constraints. In SolidWorks we call it mating. So you're going to mate the top surface to this top surface, and you're going to see it move up. So if I went to a front view, I can see that those two top edges, this one and this one, are in a line. And then the next thing I could do is I could do a right face to a right face. Okay, hit the happy check mark. And if I again go to the front, now I can see the top and the right are aligned. And then lastly, we're going to do the back face here and the front face of the rear part, and everything's happy. Okay, this is great if your parts are always symmetrical like this, and they're, say in this case, 4 inches wide, 2 inches tall. Okay, and everything is a happy world. But if you get into where the back part is still 4 inches wide and you have a design change and the front part becomes 3 inches wide, then you're going to lose your hole alignment. So this is a basic way of aligning things face to face. And one of them, the last one that I showed you, the rear face to face, is usually used when you want to have two surfaces mate together, okay? Just like they are here. Imagine it just like this. They're together, and they're not going to move off of that plane. But these other things, the top face and the right face, if they change in size, they get taller, wider, whatever, these faces will shift your hole alignment. So if I go to the front view, right now the hole's lined up nice and perfect. So let's look at another way of doing this. Okay, and let's close all this. We're not going to keep this, so I'm just going to close it. You want to save it? No. And the rear part is still up. Let's open up the front part, and I'm going to save it as front part narrow. Okay, we're going to save that. Part name is up here, and I'm going to change its original size. So I'm going to make it 3 inches wide, and you'll see why in a second. So as easy as that, I can change the size of my part. So the first thing we talked about was faces. Top face to top face, right face to right face, front and back face. Put all this stuff together. Let's do another assembly. And the first thing we're going to do again is turn on our origin, and we're going to throw the rear part in there again, let it find its center. Okay, so it's happy. And we're going to insert a component, it's the existing part, and we're going to do them narrow. Okay, so we're just going to drop it off here. So right now, the narrow part, if I did faces, the top and the top would still line up. The right and the right, you could line it up, but then your hole doesn't line up. Okay? I would still use, though, this face to this face because they're mounting flush to each other. Okay? So that's not a bad deal, but to get by this, there's two different ways we can do this. Number one is we can do mates also by planes. So if I go and open up my design tree on the front part there, I can use my right plane and the right plane of the rear part, and it's going to line those up. And then I can use the top plane and a top plane here, and that's all lined up. Okay, so if I look from the front view, my circles are lined up, has nothing to do with the edges of the part. Okay, and then lastly we can do face to face. Okay, and everything's lined up very nicely. Okay, so that's another way to do planes, but you have to remember when you're designing that if it's going to be something like this where you're going to want to use planes to mate part A to part B to part C and so on and so forth, everything has to be drawn symmetrically off of those planes individually. So this is another way to do it. Let's look at another way. So we'll get out of this, and we're going to close this assembly. We're not going to save it. And we're going to do another assembly. We're going to turn on our origin. We're going to throw the rear part, let it find its center. Zoom out a little. We're going to insert an existing component, which is the front narrow again. Alright. And another way to do it is go into View and turn on some temporary axes. So now I have the center of each hole. What I can do is I can do a mate by axis. So I'm going to grab the axis of this counter bore and the axis of this tapped hole. They're lined up. Okay? But they're not totally aligned yet because I can grab it and rotate it. To get rid of that, I can grab the right face and the other right face, not use coincident but use parallel, and it'll turn. Okay? So it'll always keep it square, so no matter where I move it, it is parallel from here to here, and it is aligned by axis. Okay? And then lastly, again, we're going to do face to face, which is great when you're doing parts that are flush with each other. So that makes a nice happy part. Okay, happy check mark, and we're good to go. So we've covered face to face, which works if everything's symmetrical and the same size. We've talked about planes. Okay, that is great if everything is symmetrical about a plane when you're designing. Axis. Axis is great for lining up holes. Okay, because you can always go back in and change your hole sizes, but as long as the axes stay in the same position, it shouldn't affect how your part is put together. Moving on, bottom-up modeling. Okay, bottom-up modeling is exactly what we just did. We've created the rear part, and then we created the front part separately in a different drawing, and we've put them together. So we have two bottom-up parts. This is very common when you're throwing simple drawings like this together. Bottom-up also refers to you have bolts that you're going to put into this. Well, a bolt is a purchased part. Any purchased part is really a bottom-up model. You're going to design it, and then you're going to bring it into your final design. So that's what bottom-up is. Top-down modeling, what that means is you have existing parts, and what we're going to do is we're going to close this out, And we're going to close this, and we're going to do a new assembly. Okay, again, we're going to turn on our origin. Rear part, we're going to find its happy center. Zoom out a little, and we're going to insert a component that's existing. We're going to browse, and we're going to make sure we're in the part mode. And we're just going to do the front part, the original one. And we're just going to drop it in here. So, we have many ways to constrain it. Right now I'm just going to mate just using faces. Okay, so it's going to line it up quickly this way, right to right. Okay, because I know this part is never going to change in width or height. And then face to face for a flush fit. Okay, happy check mark. When I bring it in, everything is constrained nicely. Again, this is bottom up modeling. I've created the back part separately, the front part separately, brought them into an assembly, and we have what we have. Top down is when you use geometry off of a part to create a new part. So if you go up into SolidWorks and you go Insert, Component, you're going to say a new part. First thing it's going to ask you for down here in the bottom, it says select a face or plane on which to position the new part. Well, I've got these two tapped holes here for a reason. So I'm going to select this face. Everything turns translucent, okay, because now a new part is shown. It's written in a dark blue. It says part of another assembly. And I can start grabbing an edge, and I can convert that edge, and convert this edge here, this bottom one, and then this far one on the left. And the next thing I'm going to do is I'm going to trim to corners. So I'm going to grab this to this, okay, and this to this. And then if I go into features, because this is a closed block, I should be able to extrude that in some direction. I say a ½ inch. Okay, and now I've created a part within the assembly. This is top down. I've used existing geometry of two mated parts to create a third part. And to take it a little further, I can grab on this right side and go to my right view. I'm going to sketch on here, and what I'm going to do, and I'm still in Edit Component, okay, that should be turned on, and this will still be in dark blue. And I'm going to go Hole Wizard, and I know these are 1/4 because I've designed it, but I'm going to put in a socket head cap screw. I got to get the right size, go from the drop down to 1/4, and then positions. Okay, well, I can use this and this other sketch from the other one. Escape once, grab the one that was just showing up, and if I hit the happy check mark, I have two counter bores created at the exact position they need to be in a top-down design. So again, it's using reference geometry from the original two parts so I can create a new part within the assembly. This is really handy when you're doing a lot of complex components or positioning them in an assembly, and then you have to start making brackets or mounting pieces to keep one together with a second. So that is top-down modeling. Clearances. Clearances are how well does something fit together. Okay, so let's get out of this edit component, and we're going to go to the front view. If I zoom in here, this is part of the counter bore, but back here is the tapped hole of the second piece. This larger hole is your clearance diameter for the ½ inch bolt to fit through as a counterboard feature through part number 1 or the front part and tap in or screw into part number 2. You need this clearance around it for that hole to get in there. If I open up this part and I look at this counter bore, and I'm going to just edit that feature. The size is the ½ inch size, or relates to your thread size, which is your major diameter. The fit, if I go close, you're going to see this little circle get smaller. Or if I go normal, it gets a little bigger. or if I go loose, it gets a little bigger. Generally, you'll always use the normal fit, okay, for the clearance of the screw going through that hole, so it has a little bit of wiggle room to get through, and then it goes into its mating hole or the tapped part. Okay? Interference is just the opposite, right? Clearance gives you clearance around the part. If that hole was too small, right, say it's a 1/2 inch screw and the screw is a 1/2 inch diameter, but you made the hole 0.490 in diameter, you're going to have to force that screw through the hole, and you have interference. Okay. Associativity is how do the parts associate with each other. Okay. Not only is associative as into how do you use planes and things to get things to mate, but associativity is also this hole lining up with the second hole behind it. It's associated, all right? It's especially associated here, where we did a top-down drawing or a model, that if the hole location changes on either one of these are associated to that part. So if I changed this location of the tapped hole on the front part and it went to the left, because this is associated with this little sketch right here, it should also move. So if I go to that front part and I grab this sketch and I edit it, okay, we gotta save this quickly, so let's just save this. We're gonna save it as test again. We're gonna save it as test 2. Save it as test-2. Okay. So it's test 2. Now let's see if we can go into that and grab that sketch and edit it. So if I change this to 0.625 and close that and then just do a rebuild with the stop sign. You can see how it moved. Okay, but it has no more associativity. So this hole has to be associated with it in a different way. So if I go into that and I edit that feature, and I'm going to go positions, this here, right, it's lost its coincident, so I'm going to delete it. And add a relation to the center of this. Let's see. Now let's go back to our right view. Try that again. If I grab the type, it's the counter bore, I grab its position, and I delete it. And again, I go into position. I can use the end of the line, that little sketch that I used, or I should be able to grab this. I select other and I grab the edge, We still want to associate this correctly. Edit this feature. Try position again. Okay. And if I go directly looking at it and I grab that little piece of the line that I changed, it will go to that correct position because that's what I changed it to. Okay, and then I can get out of edit component, and now it's associated correctly again with the hole. That's associativity. Another thing that's covered in this chapter is an exploded configuration or an exploded isometric drawing, okay, or an exploded assembly drawing. What that means is all the parts are shown. Let's just do a new assembly again quickly. And we're going to turn on the origin. We're going to put the rear part. So instead of showing them assembled, I'm going to insert another part, which is the front, just somewhere. I can turn on my axes and do a mate of this axis to this axis. Okay, so it's lined up that way. I'll do the quick face to face, and I'm just going to set it as parallel just in case that face narrows. So that will allow me to still move, but it will not allow me to rotate. There's no way I can get it to rotate. And an exploded assembly is kind of like what you see here, where it's showing the two parts and how they associate to each other, how you would bolt them together. And that's how exploded assemblies are. There are usually phantom lines or center lines going from this hole to the back of it, showing it direction that it's going together. And then in front of this you can have a bolt hanging out here, showing that it's going to go through this hole, it's going to collapse these two pieces together, they're going to be flush, and then you're going to screw it into this hole, and everything's going to come together in a nice assembly. So that's an exploded assembly or exploded configuration is what they call it in the book. Hierarchy goes back to, let's go back to test number 2. Hierarchy is which came first, the chicken or the egg. Well, the first part that you put in here was the rear part, then the front part, then this side component. Okay, that's how they're all placed in. Okay, it's also what you call a parent-child relationship, where not only is this the parent and it's telling you, where the child is going to be in relation to it, it can also tell you that further down that this now, because it came in third, is related to the first one and the second one. So this could be like, the grandfather, the father, and then the son, or the grandmother, the mother, and the daughter, right? Where grandma set the rule, right? The mother came in, she's mated to this, and then this piece is sort of mated to both of them. Okay, so it's hierarchy and a parent-child relationship between the parts. Instances. An instance is how many times does that component show up in your assembly. Like in a bill of material, you might use the same bolt 10 times. Okay, so there's 10 instances of it. You may only have to show it once. You may have to show it 10 times to show where it goes in the assembly. But when it does the automatic build generation, it is going to show you that there's a 1/4-20 socket head cap screw that's 1 inch long, and there's 10 of them used, and a bubble is going to say whatever part number that is. And finally, that brings you all around to bill of materials. So with this very simple drawing, I'm going to go into a new drawing, and we're going to try A size, see how that works. And we're going to import test number 2, and we're going to do an ISO of that. So there it is. Okay. Very simple. Again, if you type it in capitals, then down here, it already fills it in capitals. All title blocks, every note on a drawing should be in capitals. And let's try to insert a table. Okay, so that's up here, insert table, bill of materials. Specify the drawing, so you're going to just grab this view, let the orange light up. And let's go top level only. And we're going to be happy with everything. Standard bill of material. Okay, and as you move it around, it'll sort of anchor itself to the top. You sort of see it sort of catch itself there, and the same thing to the right. Okay, so we have part number 1, right? Is the rear part. Part number 2 is the front part, and part number 3 is sort of a weird name of this part. And then quantity 1 each of these. If I go into annotation and I start doing balloons, I can grab this. It automatically numbers everything. Okay? So, part number 1 is the rear part. Part number 2 is the front part. Part number 3 is the part with the funny name. How do you get rid of the funny name, you ask? I know somebody's asking it. Let's go back to the assembly itself. Okay? And there it is. Let's open up this part. And we're going to go in File, and we're going to do a Save As, and we're going to call it Side Part. Okay? And we're going to save that. It's going to change it up here. Alright, if I go into the assembly, it's going to change it in here. Okay, so rear part, front part. Now that's changed to side part. Save it. And then if I go into the drawing sheet and I hit the refresh, now it's rear part, front part, side part. Okay, everything has a name. Description. Description can tell you that it is a purchase part, and it just says a 1/4 20 socket head cap screw. Description can tell you about the material. It's the rear part is 4 inches wide by 2 inches tall and 1 inch deep. Okay, and it's aluminum. Front part, same size. It's 4 by 2 by 1, but it's CRS, which is cold rolled steel. That's the abbreviation for it. It could be CI, which means cast iron. And the side part could be made out of, let's say, plastic. All right, so it's going to say how big it is, all right, for stock size. And the stock size needs to be known when you're ordering material to have the parts made, or the machinist knows how big to sort of start the part with, sort of square it up, so then they can start machining all the fine details. It also helps with figuring out how much material you're going to need to make 100 of these. And again, of course, material, you need to know what it's made out of to make all this stuff happen. So again, quick review: to insert a table, you go into Insert Table, Bill of Materials. Okay, again, you select this, it sort of highlights with the orange. Bill of Materials Standard, which is pretty much this. Top level only. If you do parts only, that is if you have sub-assemblies within everything else. A sub-assembly is like this little assembly could be a sub-assembly placed into a larger assembly. So sometimes, do you want to have all those parts named, or do you just need to name the part sub-assembly? It's kind of up to the designer. You have to, through experience, you figure out which way is the best way to do it. So that kind of sums up everything for Chapter 7 from the Engineering Design Fundamentals Handbook. Basic constraints, understanding bottom-up and top-down modeling, clearances, interference, associativity, the exploded configuration or exploded assembly drawing, the hierarchy of stump, parent-child relationship, instances, how many of a component is used within an assembly, bills of material, okay, how they're created within SOLIDWORKS, how it does it automatically for you, and that kind of wraps it up.